All right, guys, I'm going to pause this video and I want you to go back through your notes on 3-1 if you need to. Hopefully you don't, but if you need to, go back through your notes and I want you to list all pairs for number 1 through 7. So I believe all of these will have more than one pair. So go through and list all pairs that are given what each number represents. All right, guys, here are the solutions to each of these. So take a minute and check it against what you have. And then if you got some incorrect, just make sure you know why they're incorrect so you can fix it. All right, guys, so here's 4 theorems that we're really going to hit hard, and these are going to kind of carry with us for this entire chapter. So we have the corresponding angles theorem, alternate interior angles theorem, alternate exterior angles theorem, and then the consecutive interior angles theorem. So notice all of these say when two parallel lines. So these only apply if the two lines are parallel, okay? These only apply when the two lines are parallel, okay? And notice that when these two lines are parallel, all this theorem says is corresponding angles are congruent. Okay? When the lines are parallel, alternate interior angles are congruent. When the lines are parallel, alternate exterior angles also congruent. Now here's the odd man out. Consecutive interior angles when lines are parallel, they're not congruent. They are supplementary. All right, let's look at this example here. Now, using previous theorems and the ones we just learned, knowing one angle, we should be able to find the other 7. Now, notice these lines are parallel. The 2 arrows indicates that. All right, so let's go back to chapter 2. So what do we know about vertical angles? Okay, well, vertical angles are congruent. So if this is 120, that means angle 4 has to equal 120 as well. Okay, now if we look at this 120 and angle 2 are a linear pair. So what do we know about linear pairs? We know that linear pairs are supplementary. So if this is 120 and it's supplementary, that means angle 2 has to equal 60. And if angle 2 is 60, what does that mean about angle 3? Angle 3 is also 60 degrees. Okay. Now, this is when we need to learn or to understand the theorems of this chapter, okay? So, we know this is 120 degrees, and you can do this several different ways, guys. I always go to corresponding angles first, so if this is top left, this is top left in the right intersection point, okay? And the corresponding angles theorem tells us that when these lines are parallel, corresponding angles are congruent. So that means angle 5 has to equal 120. Okay, now we're back to vertical angles. If 5 is 120, angle 8 has to equal 120. Okay, then we go to linear pairs. So if this is 120, 7's a linear pair with 8, so they are supplementary. So angle 7 is 60. And then 7 and 6 are vertical angles. So angle 6 is also 60 degrees. So as you can see, when these two lines are parallel, if you know the measure of one of the angles, you can find the measure of the other 7. All right, let's look at the examples down below now. So on this first one, it says find the value of x. So we're given that this is 136 and this is 7x plus 9. Now, these 2 angles that I circled, these would be the same side exterior angles, but notice we don't have a same side exterior angle theorem. But what we do have is an alternate exterior angle theorem. Okay, so the alternate exterior angle theorem tells us that alternate exterior angles, if lines are parallel, are congruent, right? And we do know these lines are parallel because of this and this arrow right here. All right, Well, if this blue angle's 136, angle 1 and and this 136 degrees, they have to be supplementary because they're a linear pair. So this has to be 44 degrees. Okay, so 180 minus 136 is 144. That's how I got it. So now we know that the two red angles are congruent, and therefore I can set up an algebraic equation that 7x plus 9 equals 44. Now it's just algebra. So 7x equals 35. Divide by 7, I get x equals 5. All right, let's do this next one. We have 115 here and x plus 5 here. So these two circled in blue, they're not like an angle pair combination that we learned, so we can't really do much with them. But angle 4 is vertical to 115, so angle 4 has to equal 115 as well. Remember, vertical angles are congruent, so this is 115 degrees. Okay, now do notice that it's given that these lines are parallel. Here's an arrow, here's an arrow. So these are parallel lines. Now, if I look at this angle 4, which is 115, and this x plus 5, these would be consecutive interior angles. And we do have a consecutive interior angles theorem, which tells us that when we have consecutive interior angles and these lines are perpendicular, that consecutive interior angles are supplementary. Okay, well, if you know what supplementary is, that means they add to 180. So I can say 115 plus x plus 5 equals 180. And now here we have an algebra problem, so 120 plus x equals 180. Subtract 120 on both sides. I get x equals 60. All right, let's look at example 2. We are going to write a proof. Okay, so I'm going to have my T-chart here. Okay, it says prove that if two lines, or if two parallel lines are cut by a transversal, so we have two parallel lines. I'm going to write parallel here and here. Let's call this, I don't know, line M and line N. You can call it whatever you want. Are cut by a transversal, so here's our transversal. Oops, that's a straight line, guys. So we'll call that T. Then pairs of alternate interior angles are congruent. All right, I'm just going to go through and label these angles. So here's angle 1, angle 2, 3, 4, 5, 6, 7, 8. That'll just make it a little easier. Okay, so we are given that the lines are parallel, so M is parallel to N. And we want to prove that alternate interior angles are congruent. So I'm just going to pick a pair of alternate interior angles. I don't know, 4 and 5 are alternate interior angles. So I'm just going to say angle 4 is congruent to angle 5. All right, so now I'm going to write a proof for this. So I'm going to start with my given. So I'm going to say line M is parallel to line M. That's given. Okay. Now, if they're given, if these two are parallel, would you agree that angle 1 and angle 5 are corresponding angles? Angle 1 and angle 5 are corresponding angles. That's just by definition of corresponding angles. Okay. Now, what do we know about corresponding angles when the lines are parallel? When the lines are parallel, we know that corresponding angles are congruent. That's by the corresponding angles theorem. Okay, well, that's angle 5. How do we get angle 4? Well, look, guys, what do we know about angle 1 and angle 4? So angle 1 has to be congruent to angle 4 by the vertical angle congruence theorem. Okay, now notice angle 5 is congruent to angle 1, and angle 4 is also congruent to angle 1. So that means that angle 4 has to be congruent to angle 5. Guys, two things that are congruent to the same thing are congruent to each other. And that would be the transitive property of congruence. And if you guys want to do substitution would work there as well. All right, last example. So it says when sunlight enters a drop of rain, different colors of light leave the drop at different angles. The process is what makes a rainbow. For violet light, measure of angle 2 equals 40 degrees. So right here it says angle 2, I'm just going to write 40 degrees. Okay, now it's probably hard to see on your paper because it's in yellow, but there is an arrow here and an arrow here, meaning that these two lines are parallel. Okay, so the question is, what is the measure of angle 1 and how do we know? Okay, well, if you guys notice, angle 2 and angle 1 are what kind of angles? Okay, angle 2 and angle 1 are alternate interior angles. And since the lines are parallel, alternate interior angles are congruent by the alternate interior angles theorem. Therefore, angle 1 is also equal to 40 degrees. Okay, and that's it for section 2.